video, I'll be teaching about oxidation and the reduction reaction. And I won't be teaching them as separate topics, but I'll be teaching them as one single reaction called as a redox reaction. Now that's not a word that I just made up, that's really a scientific word, and you can even find it in a book if you want. Otherwise, you can just rely on me and learn what redox reaction has to say. Before that, I want to teach you what oxidation and reduction means separately for just a moment. So, oxidation. What can you think of this word? Oxidation. Okay. Oxidation really means something that adds oxygen, meaning I have a compound in which I am adding oxygen. Or, here's a caveat, or you can even remove hydrogen. Okay. So if I have something from which I am just removing hydrogen, is that an oxidation reaction? Well, yeah, it is. And is there something like a complete set of rules in which I can say is this an oxidation or a reduction reaction? Well, actually both of them occur simultaneously, and that will be very clear with the example that I'll be giving you. So just now I told you what oxidation is. Let's see what reduction has to say. Well, Mr. Reduction, what do you say? Okay, reduction says this. Whenever from a chemical substance I remove oxygen, okay, yeah, you just got it. It's just the opposite of oxidation. So whenever I remove oxygen, the second one you can guess, or whenever I add hydrogen, that's called as reduction reaction. And why did I say that they don't occur at the same place, or rather they do? That's why here comes the redox reaction. This is not a word that I just made up, it's a scientific word. You can search for it online, you can listen to me, or you can go and search your book. But I know nobody of you here wants to go through the book. So let me just tell you. What redox reaction is actually, it's the combination of both reduction as well as oxidation reaction. Now how does that occur? Well, it's very, very simple. Let's understand it with an example, a cute looking example. It's Fe2O3, that's ferrous oxide, plus CO, that's carbon monoxide. Okay, CO2 is carbon dioxide. Why mono? Because it's only one oxygen. So it's carbon monoxide giving me iron, that's Fe, ferrous, plus CO2. What is CO2? Carbon dioxide. Okay. Now, how can I say this is a redox reaction? Well, listen to me. In the product, we have Fe2O3. Okay. Fe2O3 is a chemical substance that's called as ferrous oxide. It has oxygen, meaning it's already there. Oxygen is already there. After that, see the product. Is iron alone? Yes, it is. Meaning oxygen has been removed. So what happens from this iron, from a Fe, what happens is reduction reaction. Fe2O3 becomes, yeah, just say it's Fe, meaning that's my reduction reaction. And where comes the combination, or rather the oxidation reaction? Here it is. You have carbon monoxide, right? Okay. There, do I have carbon monoxide? Well, it seems that I do not have carbon monoxide. I have carbon dioxide. Now, what is the difference between carbon monoxide and carbon dioxide? Carbon monoxide has just one single atom of oxygen. Carbon dioxide has two atoms of oxygen. So, this means that oxygen has been added to my carbon monoxide, meaning carbon monoxide has been oxidized and my ferrous oxide has been reduced. Here comes the reduction reaction. Now we can balance the equation, because till now we have been just forgetting this all, and believe me or not, this balancing is really, really, really important, not just for you right now, but for any case, because science is incomplete with the balancing. Why? Because somebody long ago said, mass can neither be created nor be destroyed. Yeah, so let's just go and see how do we do balancing of chemical equations right now.